Hello guys, can everybody hear me? Yes, if you can, then send me an emoji or give me some text. Right. If you can hear me, then we will start our today's walkthrough. Yeah. Okay. So yeah, you say it's okay. Then we will start. Okay, then we will start. So for the first question, yeah, it's about 1, 2, 3, 1, 2, 3 divided by 7, divided by 11, divided by 13. So you can see 7 times 11 times 13 is something you have already know, right? 7 times 11 times 13. You know it is 1001. So it is 1, 2, 3 divided by 7 divided by 11 divided by 13. It is what? It is 1, 2, 3, 1, 2, 3 divided by these things timing up together 1001, right? So it is a chair number, and you know that it is 1, 2, 3 as the final answer here. So we know this one is 1, 2, 3. Okay, everybody understand this? Then we are going to our second question. So yeah, it is something about the new definition here. So we know A star B, it is A plus A over B, and we want to calculate 20 times this kind of thing. So how can we do it? So first, you can try to understand the pattern here, right? You can try to understand this pattern here. So we know A star B is A plus A over B. So 2 star 4, it is what? 2 plus 2 over 4, right? So we know it is 2.5. Then we know the things inside the bracket, it is 2.5. So the answer here is 20 times 2.5, right? So we know it is 50. Yeah, so the answer here, 50. Okay. Then we are going to have our question 3 here. So question 3, among the natural number not greater than 10,000, how many numbers satisfy these conditions below? First, divisible by 24. Second, divisible by 7. Third, divisible by 28. So we need to think about one thing, right? 28 here, it is what? It is 4 times 7, right? So if we have a number which is a multiple of 28, it is what? It is always a multiple of 7, right? So it is divisible by 28, also divisible by 7. So if the number is not divisible by 7, but we want it to be divisible by 7, this is a contradict situation, right? This is contradict. So we know we have 0 numbers giving you these kind of things, right? 0 numbers satisfy these conditions. So here, none of the above is correct, right? This one you choose none of the above. No numbers satisfy. Okay, then we are going to question 4. We have adjacent letters and the minimum number of swaps. So from A, B, and N to banana. So what should we do? So for this, we need to make B and N going left. Right, we need to make B and N going left. And we can see, if we go in left one grid, we will make one swap, right? We will make one swap. So we just think first, we make B go to the first letter, right? Originally it is A, B, N, right? And we make the B to the first letter, we swap it once, twice, so 3 times, right? We make it 3 times. And then the things will become what? Become B, A, N, right? And then we swap the N here. For N, we need to go in left for how many times for the first N here? First time, second time, right? 2 swap here. And after it, the things will become B, A, N, and A, N, right? Like this. So then, we need a final swap to make the N become the banana here, right? To make the N here swap with A here, so 1 swap. Then finally we will get banana, right? Our dream banana here. So we know the answer, the number of swaps, it is 3 plus 2 plus 1. Yeah, it will be equal to 6. Altogether, we can transform by 6 times to get the final answer here. The answer here is A. Alright, now question 25. The product of the two consecutive even numbers is 2024. What is the sum of the two numbers? Okay, so we just let the two number become A and A plus 2, right? These are the two consecutive even number here. And then we can know that A times the A plus 2 will give you a product of the 2024, right? They will give you a product of the 2024. And then as we know, this is an even number. So even number will give you what? Even number, we can make it as 2b, and b is an integer here, right? This is an even here. So when we make the a become 2b, the whole thing will become like 2b times 2b plus 2 equal to 2024. And then we can extract the 2 here, right? So first we extract the 2, and then we extract the 2 in the bracket. So together we can extract 2 2's here to make it into b times b plus 1 equal to 2024 divided by 4, right? 506. So we know we have two consecutive number. They time together to give you a product like 506. What are the numbers here? You just first prime factorize it, right? 506 divided by 2 is 253. And then we can make another division, divide by 11, so we know it is 23. Yes. So we know this one equal to 2 times 11 times 23, and we know it is 22 times 23. Right? So we know b and b plus 1 is 22 and 23. So how about a and a plus 2? We know b here is half of a. A is 2b, right? So here we just times the 2, 44 and 46. So we know the answer. It is asking you the sum, right? It's asking you the sum. So answer here is these two numbers we add up together so as to give you 90 here, right? We know the answer here is 90. Okay. So now question 6. Chris has bought two kinds of stickers. Normal stickers sold $3 each. Cartoon stickers sold $5 each. And we know the total spent here is 46. So she has bought at least A stickers and at most B stickers. So what is the value of A plus B? Okay. So here we need to think about the minimum A here, right? The minimum A here, it is the 46. We divide into something times 3 and something times 5, right? For the minimum, right? For the minimum, we need to make the $5 sticker as many as possible so that the total will be as least as possible, right? So here, how can we make something times 3, something times 5? 2 times 3 and 8 times 5. So then we got to know the A here is just 2 $3 and 8 $5. So 2 plus 8 will give you a 10 here. How about the maximum B? How about the maximum B? 46 also something times 3 plus something times 5. But if we want to get more stickers, the price for each sticker should be as small as possible, right? So we need to make it a $3 stickers being bought as many as possible. So that we just take 2 5 here, and yeah, 36 is the largest one, which is a module of 3. So here 12 times 3. So after it, we know B here is 12 $3 plus 2 $5 will give you a 14. So A plus B, it is just this 10 plus 14 will give you 24 here. Yeah, we know E here is the correct answer. Okay. So does anybody have some questions here? So any questions here? We can't see your camera. Oh, because today my camera has some problems. So yeah, sad. You cannot see my camera today. Okay, if no questions, then I continue here. Right, if no questions, then I continue here. So question 7, question 7 is easy. So it is about you know the parameter, you know the area, then you can find the answer here, right? So we know the parameter here for the large square is 48. So the parameter, we know it is the 4 side lengths of the square. So it is 4 times 12, right? We know each of the side lengths here is 12. And then 16, we know it is 4 sides of the side lengths for the small square, right? So each square side length, we know it is 4 because it's 4 times 4, right? So we can know the blue part. Blue part is the total minus the yellow part, right? The total part, we know it is 12 times 12, which is the square of the side length 12. And the yellow square, we know the side length is 4. So it's 4 times 4. So we know it is 144 minus 16. So 128 is the final answer, right? So here, 128 is a blue shaded part. Okay, question 8 here. Question 8 here, I think it is easy, right? So for this, you just observe the second and the third column. You can see from second to the third, right, we flip it upside down. From the second to the third, we flip it upside down. So here to here, also flip it upside down. So among it, which one is flipped upside down? C here, right? We know that C is the correct answer. We know C is the correct answer. Okay, question 9. Yes. Question 9, what is it? So Aiden needs 24 hours to finish the job alone. Oh, it is about a rate problem, right? It is about a rate problem. So after Aiden and Beck spent 8 hours to work for a job together, and then, yes, Beck works 4 more hours to finish the job. So how many hours did Beck need to finish the job? So this one, first, we just set the work being 1. Right? So the rate of A here, we know it takes 24 hours to finish the first job, right? Finish the whole job. So it is 1 over 24 per hour. Then we can just express their workings by another way. Why? Because we know Aiden and Beck first spent 8 hours to work together and Ben worked for 4 more hours here, right? So we just set rate of B per hour. So we know first they work together for 8 hours. So like this, right? We plus the rate together and times 8. And then B work for another 4 hours here to finish the whole job. So we know the total of their work being done is also 1, the whole work. Right? So here it is, you just time it. 1 over 3 plus 8B plus 4B is 1. So here we know 12B here is 2 over 3. So B here is 1 over 18. Right? B here is 1 over 18. So we know the answer is the total of work divided by the rate of work. So it is 18 hours. Right? It is 18 hours. Okay. So this is a rate problem. And now let's go to the question 10 here. Question 10 is a number matrix, okay? So we want to know the sum of, yes, 3 times 3, 4 times 4, and we know the sum of n times n is 5832. What is the n here? So first you need to observe the figure here, right? Once you observe it, you can find, oh, we can form the pairs here. We can form the pairs. 1 and 5, we pair them up. It is 3 and 3, right? And how about the second? 2 and 4. We pair them up, we can also form 3, 3, 3, 3. Right? So it is a 3 times 3 matrix. 4 of 3 here. So how about the second? We pair 3, 3, 3 with 5, 5, 5. You get 4, 4, 4, right? And if you pair 2 and 5, you can get also, if you pair 2 and 6, you can also get 4 and 4, right? How about 1 and 7? You pair them up together, also you can get 4 and 4. Right. So it is in 4 times 4 matrix. 4 of 4 here. So we can calculate the sum. Right. We can calculate the sum. The sum here, it is just 3 times 3 for the number of 3's here, and we know each one is 3, so 3 cubed. And this one's sum is 4 times 4 fourths here, and each one is 4, so it is 4 cubed. So now we know n times n squared, we have a sum of 5a32. So 5a32, it is a sum of n cubed. So n cubed here is 5a32. So what is the n here? So do you need to calculate it one by one? No, right? Although you don't know what cube here is 5a32, right? You can still get the answer here super easy. Why? Because you can use the last digit here to help you. What is it? If we have 15, right? We have 5 times 5 times 5. The last digit here must be 5. Must be something 5. It's not equal to 2, right? No. So how about 16 here? 6 times 6 times 6. The product's last digit is also 6. So, not 2. Throw it away. 7 times 7 times 7. The one digit for the product, it is 9 times 7 is 3. Yeah, it is 3 here. Not 2. And 8 times 8 times 8. 4 times 2 is 32. Yes, it is something 2. Correct. And how about 9 times 9 times 9? 19 times 19 times 9, 19 is 9 times 9 times 9 for the ones digit, and we know it is something 9, also not. So you can see, among these 5 choices, only 18 cube will give you the one digit here being a 2 here. So that's why we choose 18. You can examine it, 18 cube, of course it is 5a32, but we just skip it, because you have already get the answer here. Right? You know here, you can just try the last digit here and help you solve it super easy. Okay, so for the 10 questions here, do you have any questions? Do you have any problems? Okay, if no, then I just continue here. Right. So let's go to this part. So question 11 here, yeah, we have a square. So square will give you what? Square will give you a 90 degree, right? And also we know the area is the square of the side length. So we know the two legs here is 4 and 5. Do you have something interesting here? So this is the side length, right? So based on this wide angle here, the side length here, it is just, yes, we know the side square here is the 4 squared plus 5 squared. Why? Because we know it is a wide angle triangle, right? Use the Pythagorean theorem. So we know the side square here is 16 plus 25 will give you 41. And we know the area of the square is also the square of the side length. So it's the area. Right, so we know the area is 41. So answer here, 41 here. Right, answer here 41. Okay. Question 12. Okay, is a ratio problem. So here we have boys. Yes, we have girls. Yes. So original, yeah, in the before, we know number of girls is 4/7 of the number of boys. So we can set the boys here as 7 units, girls here as 4 units. Then after it, right, after it, we know half of the boys have already gone. So it is divided by 2, right? So the boys being left is 3.5 units, and then girls still here. So we know the girls state it is exceeded by the boys by 1. So 4u minus 3.5u is the percent exceed, right? We know it is 1 here. So 0.5 units, it is 1. Units here is 2. So we know the total, right? The total here, it is the number of boys, 7u, plus the number of girls, 4u, altogether 11u, and we know u here is 2. 11 times 2, 22. Right? So we have 22 students in this class. Alright, question 13. Yeah, question 13 I think is also not hard. Once you understand the basic theory of calculating the area of triangles, you can know it. Right? So now we know a parallelogram ABCD is 2023. And yes, E and F are the 2 points on it. So we know AC is 7EF. So AC here, right? We know it is AE plus EF plus FC. It is 7EF. Right? So we know AE plus FC will be 6EF. So AE plus FC to AC will be equal to 6EF to 7EF, which is 6 to 7. So how about the shaded? The shaded, you just do the base and height and you can see this is a height, right? We name it as H. This is also a height. Because it is a parallelogram, this is also H. So you can see the base here is AE and CF. The height here H. How about the ADC here? The ADC base is AC and the height is also H. So that's why we can know the shaded part. The base of AE and FC to the area of the triangle ACD, which is the base of AC here, it is just the ratio of their base, AE plus FC to AC. So it is also 6 to 7. And we know the area of the ACD is a half of the ABCD, right? It is a half area model. So we know it is a half of the 2023. So we can know the shaded, right? The shaded here is 2023 over 2 times 6 over 7. So it will give you 3, this one divided by this one, 2023 divided by 7, 289. Yeah, so this 289 times 7 will give you 867. Yeah, so 867 is the final answer. Alright. Question 14. Aiden is packing a batch of cookies, and yes, 4 cookies, 20 cookies left unpackaged, 6 cookies, 24 unused. Yeah, so we can just set X bags, right? So here, the cookies will be like this, right? 4 bags per cookie, so 4x, and 20 left unpackaged. It will be equal to 6 in a package. And still 24 not used, right? So we still lack of 24 times 6 cookies. So you can see it is 144 plus 20 here, right? Equal to 2x. So 164 will be equal to 2x. X here is 82. So the number of cookies is just 84 bags. Each bag we have 4 cookies in it. And also 20 cookies being left. So it is 348 here, right? So the answer here is, this is not 24, it is 82. So it is 348. Yeah, this one is 348. Alright. Question 15. Question 15, I think it is a calendar problem. Yeah, it is a calendar problem. So in October 1911, we have 4 Saturdays and 5 Sundays. Then 28 October 1011 is what? So in October, we have how many days? In October, we have 30 days, right? Oh, not 30 days. We have 31. Yeah. In October, we have 31 days. So if in October we have 31 days, then we can know it, right? 31 divided by 7, it is 4 weeks remaining 3 days, right? 4 weeks, remaining 3 days. So you can have a try, right? So you can have a try. So we have Sunday to Monday to Tuesday, Wednesday, right? Thursday, Friday, and Saturday. And we have first week, second week, third week, and fourth week. Right? We have 4 weeks here. And where should we put the 3 days? If we put the 3 days here, right, we will have how many Saturdays? We'll have 5 Saturdays. It won't be the case, right? It won't be the case. So of course we cannot put the Saturday, the first day here. So where are the remaining 3 days? We can only put it after the 4 weeks, right? So Sunday, Monday, and Tuesday. So yeah, we know this is the last day. This is the 30th, 29th. So of course 28th is here. So we know 28th here, it is a Saturday. So the answer here is 6, right? So the answer here is 6. Alright. So question 16. Oh, question 16 is a number puzzle here. So we have A, B, C, D, E representing 5 letters, and yes, each is a unique even number here. And what are the different letters for? Oh, and what are the letters for E? So here, which one should we start first? We should start first with the AD here. Do you know why? Because for AD here, there's nothing here. There's nothing here. So what will make the A19 become AD? Only this carry over here, right? Only this carry over. So the carry over here can only become 1. Do you know why we can only make carry over become 1 here? Because it is the 9 plus C, right? Before it is 9 plus C. If the C here is a maximum 8, it is 17, smaller than 20. So of course we cannot have a carry over of the 2 here, right? So we know AD it is 19 plus 1 equal to 20. So A here is 2, D here is 0. So we just fill in A and D, right? So 2, 0, and this one 2, this one 2, this one 2. Yeah, that's it. So which one should we start next? So once you see we A here have 2 here, right? You can just focus on this 992. Why we focus on this 992? Because it is almost 1000 here. It's almost 1000 here. And what will make you a 992? It is this column, right? It is this column, the middle one. So the middle one, it will give you 2BC, right? 2BC. And times a B. Right? And times a B. So 2BC times a B, it will give you a 992 here. Right? It will give you a 992 here. So what will the B become? Can we become a 4 here? Yes, we can B become a 4. Can we make it a 2? If it is a 2, how can 2BC times B with a 992? Of course not, right? Can B become a 6? Even if everything is 0, 200 times 6 is already larger than 1000, right? It's 1200. So B cannot become 6. So B here is only 4. So we know 4, 4, 4. Right, B here is 4. So then we can focus on what? We can focus on the C here, right? So you can see during the first column, right? This column, the orange one. The 2, 4, C, we times the C will give you 19C4 here, 19C4 here. So you can just use the last digit here. If the first case, right, the first case, C equals to 6, because 0, 2, 4, 6, 8, right, we still have 6 and 8 not being used. So first C equal to 6 and second C equal to 8. So C equal to 6. C times C it is 36, right? The last digit here is 6, not equal to something 4, right? Not equal to something 4. So how about C equal to 8? C times C will be equal to 8 times 8, 64. Yeah, it is something 4. So of course, we know C equals to 8 is the correct answer. So C here is 8. And the only C being left, it is the E, right? And we know 0, 2, 4, 6. 0, 2, 4, 8, right? This 4 number has already been used. So the only even number being left here is 6, and we know it can only become the D here. So we know D only become the E here. So we know that E here is 6, right? 6, 6. So then you can just try it, and I'm sure that you will get the correct answer. So E here will be the 6. Okay. Question 17. Oh, question 17 is a journey problem. So we have Chris and Dylan first swimming at the same time at the same side, and Chris swims 20 meters, Dylan swims 24, and after Dylan reaches, he turns, and after 30 seconds they meet. So what is the diagram be like? You first draw a diagram to help you, right? So this is the hull of the pool, right? So we have Dylan first swim from this side to this side and turn back, meet with the Chris. How about Chris? Chris first swim from here to here, right? And then Dylan reaches another end. Then he swims again for 30 seconds. So then they will meet together. So the total time for them to travel for this part is what? It is from Dylan reaches the other end to he meets with the Chris, right? So between them we have how many seconds here? We have 30 seconds, right? We know here it is 30 seconds. So once we know here it is 30 seconds, what can we do? We can know the distance, right? The distance is the 30, which is the time, times the both of their speeds, right? The sum of the speeds. For Chris here, we know it is 20 meters per minute. And for Dylan, 24. Right? So we know the total distance here. It is 30 times 20 plus 24. Is that correct? Is that correct? If you do it, you will make a wrong answer. Why? Because you can see it is 20 meters and 24 meters, right? If you do it, you can see it is meters per minute. 20 meters per minute, 24 meters per minute. And here, the 30 is what? The 30 is the seconds here, right? Most of the students will get it wrong here. So, the 30 seconds, it is what? It is 0.5 minutes, right? It's 0.5 minutes. So here, is it 30 times the sum of the speed? No. We need to make the units become the same, right? So, it is 0.5 should be the final time for it, right? So 0.5 times the total of the speed. This time is correct, right? So here it is 22, right? We know the distance here is 22 meters. So what will make the 22 meters here? Right? Is the traveling distance, the difference of distance between Chris and Dylan here, right? It is the difference of distance between them. So here, for every second, Dylan will travel how many meters more? 24 minus 20, right? This is the difference of speed. We know every minute, Dylan will travel 4 meters more. So this is the difference of speed. And we know the total distance here, it is 22 meters, which is from they start at the same point until Dylan reaches at the end, they have a difference in distance for 22. So every minute they will have a difference in distance for 4. So how many minutes did they travel? It is the 24 divided by 4. So okay, now we know Dylan traveled for 5 times 5 minutes, right? To reach from this end to the other end. So it is asking you how long is this swimming pool. So you just times the total time, right? 5 times 5 minutes with Dylan's speed. So Dylan's speed we know it is 24, right? 24 meters per minute. So it is 5 times 5 times 24. 132 is the final answer. So we know the length of the swimming pool, it is 132 meters. Okay, so you get 132. Alright, any questions for this 17, for the about the first half of our today's paper. y82. You just solve this equation, right? You move 20 and 144 to one side, so it is 164. It equals to 6x minus 4x, so it will be 2x. 164 2x. X here is 164 divided by 2. So 82 here. Okay. Oh, no questions? Good. No questions, it's good. So if no, then I continue here. Alright. So let's go to this. Question 18. So in Tom's piggy bank, there are 3 types of coins: $1, 50 cent, and 10 cent coins. So we know the total count is 100, and the total amount is $35. So yeah, we have 3 types, right? $1, and we have 50 cents, and we have 10 cents. We have these 3 parts, right? So after it, what should we do? We just use the ratio here, right? We just use the ratio. So we know the total value of the 50 cent coins is twice the total value of $1. We know $1 it equals to 2 times 50 cents. Right? It's 100 cents. So we know the total money for 50 cents is twice the total value of $1. And for the same amount, the number of coins is also 2 times. So if we set the $1 coin has X of the amount. So what is the number of 50 cents? First we times 2 to make it be in the same total value, and then we times another 2 to make it twice, right? To make the total value become twice. So 4x here. First times 2 and then times another 2, so 4x. So how about the 10 cent? In total we know we have 100 coins. So we just minus these other 2 categories, right? So now you get it. So we know the number of each categories. So we can just make use of the total amount here, right? Make use of the total amount here. So $35, it is what? $1 coin and with X numbers. And 50 cents, we know it is $0.5 times 4x as a number here. And also 100 minus x minus 4x. This is 100 minus 5x. And each of them, we know its value is $0.1. Right? And then we know 35 here. X plus 2x plus this 10 minus 0.5x, right? You just make the user distribution law here. So 10 minus 0.5x. So we know 25 is 25 is 2.5x. X here is 10. So what is the answer? Answer is the number of 10 cent coins. So total here 100. You minus these 2 categories, right? So it's 100 minus 10 minus 40. So the answer here become 50 here, right? The answer here become 50. Alright. So yes, this is how we do it. Any questions? If no, then I continue. Okay, so now let's go to the question 19 here. Now let's go to the question 19. So the sum of digits of a positive integer is a multiple of 9. The number is called a good number. So how many 4-digit good numbers are there? Okay, so here, yes, sum of the digits multiple of 9. What do you think about? What do you recall? You should recall about the divisibility rule, right? Sum of digits multiple of 9, so it is the same as the number multiple of 9. Right? It's the same as the number multiple of 9. So here it is asking from all the 4-digit number. The range here is 1000 to 9999. Right? All the 4-digit number here. It is asking you how many multiple of 9 here. Right? How many multiple of 9 here? So what is the largest multiple of 9 but smaller than 1000? It is the 999. Right? And then we get 1008. And then we get 1017. Right? And then blah 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 until we get 9999, which is another multiple of 9, and then we get 10008. So for 999 here, we know it is 111 times 9. This is 112 times 9. This is 113 times 9. Until blah blah blah, we get 1111 times 9 here. Right? We get 1111 times 9 here. And this one is 1112 times 9. So all the 4 digits, which is a multiple of 9, is from 112 times 9 until we get 1111 times 9. So we have how many numbers? You just use the 1111 minus the 112, right? And plus, as we take the both ends, we plus 1 here. Right? It's something like the planting tree problems. So it's 999 plus 1 will give you 100. Not 100, 1000. I'll give you 1000. Yeah, this one. Alright. Okay, now we will get question 20. So question 20 is something about finding the patterns. So here, first you list all the things you want based on the pattern here, right? So for pattern, we have the first pattern, the second pattern, the third pattern, blah blah blah, until the number of patterns we want, right? And then think about the parameter. We know the silence is 1. For the first pattern, you just count 1, 2, 3, 4, 5, right? 6, 7, 8, 9, 10, 11, 12, 13, 14. So 15, 16, 17, and 18, right? The 4 in this inside, right? In this inside. So it is 18 as a parameter, right? Or you can just count in another way. 1, 2, 3, 4, right? You can just count in a clockwise direction. It's also okay, right? 2 ways to count it. And how about the second pattern? You can also count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Yeah, we have 28. Right, we have 28 as a parameter. And how about the third? The third you also count, right? After you count, you will find it is 38. And then, what are we also focusing on? It is asking you contains how many squares. So we also need to know the squares. Right. The first pattern we have how many squares? We have 8. The second pattern we have 13. The third pattern you just count we have 18. And then you can find the pattern here, right? From 18, 28, 38. Every number we just plus a 10 here, right? And for squares here, 8, 13, 18. Every number we just plus a 5. Right? Every number we just plus a 5. So we can know it. It is asking blah 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 until we get the parameter is 198. So after it, how can we find the pattern here? So this one is always 1 times 10 plus 8. Right? This one is 2 times 10 plus 8. This one is 3 times 10 plus 8. So this is something times 10 plus 8. Right, plus 8 will give you 198. So this is something we know it is 19 here. Right, and we know 8 here it is 1 times 5 plus 3. This is 2 times 5 plus 3. 3 times 5 plus 3. So this one is 19 times 5 plus 3 will give you 98. So yeah, we know 98 is the final answer. Right, 98 is the final answer. Alright, so any questions for these first 20 questions? Right, any problems here? Why is it 4x for the previous equation? Let me have a look. Because we know $1, right? I give you an example. So if we make $1 having a total value of 2, for example, so 50 cents, it is having a twice, right? The total value is 4. So if we divide the number here, 2 divided by $1, 2, right? But $4 divided by the 50 cents, it is 4 divided by 0.5, 8. So you can see it is 4 times. So this is 4 times. Why? Because $1 equals to 2 times 50 cents. So in order to get the same value here, the number of the 50-cent coins should already become twice. And the total value another twice. So 2 times 2, 4x here. Do you understand this one? Yeah, you need to think about the values. Okay, so as everybody understands this part, then we just continue here, right? So for this 21, yeah, it's about the calculation. Just the fraction calculation here. You just do it again, and again, right? You slope 1 layer, second layer, third layer, fourth layer, and then, yes, you know the answer here, right? It's just about the calculation. So for this, we know 265 over 119 is what? You just make it into the mixed fraction. It is 2 and 27 over 119. So we know 27 over 119, this is this part. And then we just take the reciprocals. So you can see 4 plus 1 over 2 plus 1 over 2 plus 1 over a. It is a reciprocal of 27 over 119. So it is 119 over 27. Right? And we know it is 4 plus 11 over 27. So of course, we can just extract them out. I use another color. We can just extract them out. This part. It will be equal to 11 over 27, right? And you take the reciprocals again. So 2 plus 1 over 2 plus 1 over a. Yeah, it will be the reciprocal of this one. So 27 over 11 equal to 2 plus 5 over 11. So yeah, you just throw another layer, right? This one equal to this one. So 2 plus 1 over a, it is equal to 11 over 5, which is also 2 plus 1 over 5. So then we know this part equal to this part. A here is 5. Yeah, it's all about the calculation. You just make the improper fraction into the mixed fraction, and you minus, you get the part, take the reciprocals, and do it again, right? You just take it for 4 cycles and you know the answer. Right? This is nothing hard. Okay, question 22. It's about the angle calculation. So we have 2 triangular rulers. Put together, we know C and F, they are 90 degrees. 45 and 30. So here we can first think of the A and B. How can we transfer them? So first, we can just take the angles here, right? We can just take the angles. So triangle A here, right? Not triangle. Triangle alpha. The alpha here is what? It is the A plus this angle 1, right? This one. So it is, we know angle A is 45. So 45 plus angle A, angle 1. How about the B? You just name it as the angle 2. Right? You just name it as angle 2. So this is angle B plus angle 2. Angle B, we also know it is 45 degrees. And then we can make use of the cross angles. Right? They are the cross angles. So angle 1 will equal to this one, angle 1. But this one is also angle 1. And this one also angle 2. So then, if we take angle 1, angle 2, and the E here, you will find something interesting. Angle 1 plus angle 2 plus the E here. It will give you what? It will give you the interior angle of a triangle. So we know the value here is what? We know the value here is 180, right? In every triangle, the sum of the interior angle is always 180 here. So now we can know that what? We know angle E is 60, right? We know this part is 60. So we know angle 1 plus angle 2 here is 180 minus 60 will give you 120 degrees. And the answer is asking you alpha plus beta. So it is angle 1 plus angle 2 plus 45 plus 45. Right. So it is 120 plus 90. So the answer here will give you 210 degrees. Right? The answer here, 210 degrees. Okay? So any questions here? No questions? Okay, then just continue. Nobody asks questions here. Okay, question 23. This is a very typical permutation and combination problem. Right, this is a typical permutation and combination problem. So, a mountaineering team, we have 8 members and we have 4 students here. Yes, Simon, Harry, Wendy, and Lucas carrying a first aid kit and cannot stand adjacent to each other. Then we can use what? We can just make them go out and insert them into the queue again, right? So then we can make sure, yes, they are not adjacent. So first, we take out Simon, Harry, Wendy, and Lucas. We take them out. And then, what can we do? So altogether we have 8 students. We just make them going out. There are 4 members being left. So it'll be like this. Blah, 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 blah. We have 4 members. And where can we put the Simon, Harry, Wendy, or Lucas? We just put them between them. Right? We just put the 4 members between them. So we have how many vacancies here? We have 5 vacancies. So 5 vacancies, we choose 4 to place them. Right? With 5 vacancies, we choose 4. So this is like 5C4, give you a 5. Right? 5C4. And then, just for example, we just choose this one, I use another color. I just choose this one, this one, this one, this one, and this one. So how can we arrange the different groups, right? So Simon, Harry, Wendy, and Lucas, how can we make them stand in sequence? How many ways are there? It's about a queuing problem again, right? So among them, 4 people, 4 vacancies. So 4P4, right? This is for the Simon, Harry, Wendy, and Lucas. 4P4. So we know here is 24, right? So how about the other 4? Also 4P4, right? 24. So then we know for the students or for the members except Simon, Harry, Wendy, Lucas, 24 ways, and we choose to insert them 5 ways, and then the Simon, Wendy, Lucas, and Harry 24 ways. They are done at the same time, so we just multiply them. At the same time means we multiply them. So answer here is just 24 times 5 times 24. Alright, so it is 120 times 24 will give you 2880. So the answer here, 2880. Okay, question 24. Yeah, this is an aging problem. So yes, we have, just draw the age here. So when grandpa is 60, 2 times of that, okay, so we just skip it. Tom is 1 year old. So when dad is 8 times that of Tom's, grandpa is 61. So we just set grandpa here as 61 years old. So that here, we don't know. Some here, we don't know. But we know that here is 8 times, right? So we set that 8 units. And the Tom here, 1 unit. So the age between them, 7 units here, right? The age between them, 7 units. And then, let's go back to the first circumstances, right? When Tom is 1 year old. So it is how many years before it? From U years to 1 year old. Yes, we just move before U minus 1 years. So everybody's age is U minus 1 years younger, right? So how about the age for dad and grandpa at that time? So it is 8U minus U minus 1 in the brackets. So it is 7U plus 1. And how about grandfather? The grandfather is 61 minus U minus 1 in the brackets. So it is 62 minus U. And then we know it is twice, right? Grandpa's age is the twice of the dad's. So 62 minus U is the 2 times 7U plus 1. Right? So 62 minus U is 14U plus 2. So 60 equal to 15U. U here is 4. And then we want to know grandpa is how many years older than Tom. So when grandpa is 61 years old, Tom is U years old, and we know U here is 4. So 61 minus 4 will give you 57. So grandpa is 57 years older than Tom. Alright? So now question 25. So we know a 4-digit number plus the sum of its digits is 2017. So yeah, you just when you see the plus the sum of the digits and the 4-digit number, right? You think about the place value principle. So if you make the place value principle, it will be like this. A, B, C, D is the number we want, right? We plus it with an A, we plus it with a B, we plus it with a C and a D. The sum of the digits, and we know it is 2017. So it will make A, B, C, D 1000A plus 100B plus 10C plus D. This is for the A, B, C, D here, right? By using the place value principle here. And we plus A plus B plus C plus D. Will give you 2017. So if you combine them together, 1001A plus 101B plus 11C plus 2D will give you 2017. So A here we have 2 different choices. The first one, A here is 2, right? And then we know 101B plus 11C plus 2D is 2017 minus 2 times 1001, 15. So we know this kind of thing it is 15. B here of course is 0. Then 11C plus 2D is 15. So C here is 1 and D here is 15 minus 11, 4. 4 divided by 2, 2. So we know here A, B, C, D will give you 2012. Right. And the second case, A here is 1. So if A here is 1, 101B plus 11C plus 2D is 2017 minus 1 times 1001. Right? So it will give you 1016. It will give you 1016. And what is the minimum of the 11C plus 2D? It is larger or equal, not larger, it is smaller or equal to, right? It is smaller or equal to 11 times 9 plus 2 times 9 equal to 117. So we know 11C, it must be larger, not 11C. So we know 101B, it must be larger than 1016 minus 117, right? Because the 11C plus 2D is smaller than 117. So it should be larger than 899. Right. So 101B should be larger than 899. So B here can only become 9. Right? B here can only become 9. So 11C plus 2D will give you 1016 minus 909. So the answer here is 107. So we know this one, 11C plus 2D is 107. And of course, we know 2D is even, right? This part is even. 107 also even. So based on the parity here, we know this one is odd. And 11 is also an odd number. So it means C is odd. So C here, if C is 7, so 2D is 107 divided by 77. So of course, larger than 9, right? D cannot be a one-digit number, no. So how about C here is 9. 2D here is 107 minus, this one is not divided, right? Minus 99, give you 8. Right, it will give you 8. So here D will be equal to 4. D will be equal to 4. Right, D will be equal to 4. So we know A, B, C, D this time is 1994. So then we get the answer, right? The two circumstances give you the two possible answers. So the answer here is 2012 plus 1994. So these are the two occasions. You plus them together, it is 4006. Right, so the answer here, 4006. Alright. Question 26. Oh, for the first 25 questions, do you have any problems here? Say cheese. Being so happy. If no, then we go to the last 5 questions in today's paper. Yes, the last 5 questions. So yeah, let's go through it. Okay, so question 26. It's a train problem. Yeah, also a journey problem. So the train first cross a bridge, then cross a tunnel. So the first question here, we don't know the length of the train, but what do we know? We have the first case, the train passed a bridge. So the total distance is the bridge length plus the length of the train. How about the tunnel? Cross the tunnel also, the total distance is the length of the tunnel plus the length of the train. So if we divide, it will become like what? The difference in distance. It will be just the distance between the difference in distance between the bridge and the tunnel. So it will be 480 minus 320, 160. And also we know the difference in distance, it will be equal to the difference in speed. This is something you have learned in the journey problem, right? It will be equal to the difference in speed times difference in time. Oh, the difference distance is not the difference in speed. It will be equal to speed times difference in time. This one, right? So we know the difference in distance, it will be equal to speed times difference in time, and we know the speed. We don't know. How about the difference in time? This one we know it, right? First, it passed a bridge by 30 seconds, and then it passed a tunnel by 22 seconds. So we know this one is just 30 minus 22, will give you 8, right? So we know the speed. The speed is 160 divided by the time here, 8. So it is like traveling 20 meters per second, right? It's traveling 20 meters per second. So now we can know the length of the train A here, because the total distance we can already know, right? 30 seconds, and it travels by a speed of 20 meters per second. So the total distance equal to train A plus the bridge. Total distance, it is 30 seconds and the speed of 20. So it is train A plus the bridge here, 480. So train A, we know the length here is 120 meters, right? We know the length of the train A is 120 meters. So then, when the trains are passing together, right, we want to know the total time. What is the formula? So it is just the sum of the length for the both trains, 120 plus the other train is 132, right? The sum of the train lengths divide the sum of the speeds for the encountering problem, right? So the sum of the speeds, 20 plus 22. So it will be 252 divided by 42 here, right? So we know the answer here is 6 seconds. So 6 seconds. So for this question, right, you need to think about the difference in distance, and you know the formula. It is difference in distance equals to speed times difference in time. And then you make use of the formula you learned in the train encountering problem, and then you can solve it. Alright. So how about question 27? So for question 27 here, so it is a kind of number theory problem. But don't be worried, I think it's not that hard. So we have 1 to 100, and it is asking the maximum possible number. So it is asking the maximum. So the possible maximum is what? We just take the same parity, right? We need to make them having the same parity. So we just take 500, the largest one, and the largest with the same parity of it, 498. So we just take the average, 499. Right. So we have already saying, yeah, in theory, we have 499 as the largest one, right? In theory, we have the 499 as the largest one. So how can we make it, right? How can we make it? So, is it possible to form the 499? So first we have 1, 2, 3, 4, 5, 6, blah, 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 until we get 497, 498, 499, 500, right? So how can we make it? First, we can make 1 and 3 pair together so that we form a 2, right? And then 2 and 2 together, so we form another 2. Then you just see we can form a chain here. 2 and 4 form a 3, right? 3 and 5 form a 4, and then 5, blah blah blah. So until something with it before the 497, it will become 495, right? Form with it 496, form with it 497, and then 498. So then you can see we have a 498, we have a 500. So here, do it, 499. So we know this one is the final answer, right? You can just think what is the most possible, what is the possible largest value for it, and then you can just examine, oh, this is correct, right? We can make something like this. So then you can know the answer. Alright, question 20. Question 20 is something we have just learned. Yeah, it is about the half model and the triangle with the same area. So if you cannot see it, yes, I will help you through a line. So you can see we have ADBH, a square. So the most common line being connected here is you link the diagonal. You connect the AH. And then we know DEH, BEH, BCH, 56, 50, and 40. Right? So you can just make use of the half model. So for the triangle AEB and the triangle DEH, these two are the half model here, right? They are half of the ADBH. So we know the AEB's area. It is the half of the ABHD. Why? Because we know this one plus another one, it is a half. So this one, AEB, the half minus the other part, which is the triangle DEH. And we know DEH here is 56. So we know AEB's area. And then how can we form another half model here? It is the ABH, right? The triangle ABH, which is composed by three triangles, AEB and BEH and AEH, which is also a half of the ABHD. So then we can make the formula right. Because we know BEH, we also know the area here is 50. And AEB, we have already got it. So it is a half of the ABHD minus 56, which is for AEB, plus 50 plus the triangle AEH will give you a half of the ABHD. Right, this is it. So we have ABHD on both sides, so cross them out. So we know the triangle AEH, it is 56 minus 50, right? 6 here. So we know this part is 6. So then what can we use it? So if we know we have a trapezium ABCD, right? So we know we can make use of the parallel line here. We can make use of the parallel line here. So if we make use of the parallel line, what can we get? We can know we have the triangles with the same area. The triangle BHC will be equal to the triangle AHC. Right? You just think about the base. The base is both CH. And the height here is the distance between the parallel lines AB and DC. Right? So we know the area here is the same. So BHC we know it is 40. Right? How about AHC? AHC is a triangle AEB, AEH, not AEB. It's a triangle AEH plus a triangle CEH. And we know this part is 6. So of course we know triangle CEH is 40 minus 6 will give you 34 here. Alright, so the answer here, 34. Okay. Alright. Now we are going to question 29 here. Question 29 is something like the operation. So we have Aiden, Beck, Chris, and Dylan passing a ball. At the beginning, ball is in Aiden's hands. Okay, so we have 4 students here. Aiden, Beck, Chris, and Dylan. So beginning here, right? Ball is in Aiden's hands. So after the beginning, yes, pass 5 passes, and how many ways to pass it to Dylan? So after the first pass, there are how many ways for Aiden getting the ball? No ways, right? Original Aiden is getting the ball. So after pass once, right? No matter who Aiden passed the ball, Aiden will not have the ball, right? He give the ball away. So it may go to B, right? B may have the ball from Aiden, and C may have the ball from Aiden, and Dylan may also get the ball from Aiden, right? There are 1 ways after the first ball, of the first pass, right? For B getting the ball, only 1 way, get it from Aiden, right? For Chris also one way for getting the ball after the first pass. Get it from Aiden, right? So after the second pass, what will happen? So for Aiden, right, he can get the ball from the back, get the ball from the Chris, get the ball from the Dylan, right? So it is based on how many ways Blake can get the ball before it, right? So if Aiden get the ball from back, it's one way, right? If Aiden get the ball from Chris, also one way. For Dylan, also one way. So it is three ways. How about back? He can get it from Aiden. Aiden does not have ways, so zero way. How about the Chris? One way. How about the Dylan? One way. So two ways. So the same for Chris, right? Two ways. So the same for Dylan, two ways. So this is after the second pass. So after the third pass, each of them have how many ways? Aiden here, just two ways from back, two ways from Dylan, two ways from Chris. So 2 plus 2 plus 2 will give you a 6. Right. How about B here? 3 plus 2 plus 2, right? 7. C here, 7. D here, 7. And then we can try after fourth pass. So it will be 21, 20, 20, and 20, right? And then we can calculate the ways for Dylan get the ball after 5 passes. It is you add all the things from Aiden, all the way from back, all the way from Chris. So it is 21 plus 20 plus 20 will give you 61. So altogether we have 61 ways for Dylan to get the ball after 5 passes. Okay? So finally, yeah, we are going to the 30th question. Yes, finally we are going to the 30th question. So here, a natural number less than 2024 was divided respectively by 5, 7, 11, 13. So here, so if we have the maximum sum of the remainder here, we just have a try, right? So maximum. So if we divide by 5, the maximum remainder for it is 4, right? If we divide by 7, the maximum remainder is 6. Divide by 11, the maximum remainder is 10. Divide by 13, the maximum remainder is 12. And we are asking the sum of it. So plus, plus, plus. And then you can see it's 32. But is it possible? What is the number here? The number here should be the LCM, the least common multiple of 5, 7, 11, and 6, and 13, right? And as we know, 5, 7, 11, 13, they are co-prime. So if they are co-prime, the LCM of them is just multiply them together. So it is 5005. So this is the LCM of it. So it is divisible by 5, 7, 11, and 13, right? And we want the maximum remainder, which is minus of 1, right? Plus 1 to being a multiple. So this time the remainder is the maximum. So 5005, which is minus 1, will give you 5004. And we know it's absolutely larger than 2024, right? So it cannot be the case. This one is not good, right? It cannot be the case. So then we make the maximum being a little bit smaller, being 31. So what are the cases? The first case, we make it become the remainder 3 plus the remainder 6 plus the remainder 10 plus the remainder 12. This is it. Then the number of it should become LCM of the 7, 11, and 13. Why? Because here we focus on the 6, 10, and 12. We focus on these 3 numbers. They are all add 1 being multiple, right? So the number we add 1, it is a common multiple of 7, 11, and 13. So that's why we focus on the LCM of 7, 11, and 13. And we know this one is 1001. So the first number here is 1001. We minus 1 give you 1000. Right, the first number here is 1000. And then we examine it by whether it has a remainder of 3 divided by 5, right? So 1000 divided by 5, remainder 0. And then what is the next thing? We'll have the remainder 6, 10, and 12. We plus another LCM on it, right? It's 2001. Divided by 5, you can see it is R1. And then that's all, right? And we have another way. So you can just, every time we are plussing the LCM of it. So we first calculate 1001 divided by 5, it has how many remainder? Remainder 1. So 1000, remainder 0. We just plus 1 here. So remainder from 0 become a 1. It is another way. If you don't understand, you can just skip it. Because, yeah, you can just try it 1 by 1. This is a way that is a shortcut, but you cannot use it. You can just leave it away, right? It's also, you just not use it. So the second case is about what? The second case is about, we have the 4 being remainder, we have 5 and 10 and 12, right? These 4 remainders. So the number for it, first is the LCM of the 5, 11, and 13. Right, we focus on these 3 remainders because they are all plus 1 to being multiple. So the LCM of it is 715. Right, we know this one is 715. So the first number here is 715 minus 1, 714. So 714 divide by the 7 here. Because we are going to examine this 5. Right. Divide by 7 here. Remaining 0. And then we plus another 715. Right, 1429. Divide by 7, also remainder 1. So there's also a shortcut, right? 715 divided by 7, you can see remainder 1. Right, you can see remainder 1. So plus 1. Right, so plus 1. So of course, we don't have remainder 5. Right, we don't have remainder 5. So no. Let's go to the third case. The third case is what? We have remainder 4, remainder 6, remainder 9, and remainder 12. So this time, we are having 4, 6, and 12 plus 1 being a multiple. So the number here is the LCM of 5, 7, and 13. So this time you can see it is 455. Yeah, this time it's 455. So 455 minus 1 is 454. And we examine by this 9 here, right? So 455 divided by 11 here, it is R4. So 454 first divide by 11, right? Examine, you know the remainder is 3, not 9, so not good. And then you plus 455, so it is 909 divided by 11, remainder 7. Or you can just plus a 4 here, the same, right? And plus another 455, 1364 divided by 11, R0. Yeah, plus 4. And you plus it again, 1819 divided by 11, so plus 4, R4. Right, so this is it. Do we have an R9 here? Also no. So let's think about the fourth case. The fourth case. So the last case is the first 3 remainders are being the biggest. 4, 6, 10, and the last one is 11. So this time, these 3, 4, 6, 10 are the largest. So we just focus on the LCM of the 5, 7, and 11. So we know it is 385. 385 divided by 13, we know it is R8, right? So first, the first number we start is 385 minus 1, 384 will give you remainder 4, remainder 6, remainder 10. So then 384 divided by 13 remaining 7 here. And also plus a 385, right? 769 divided by 13, remaining 4. Or you can just plus an 8 here, right? 15. So 15 divided by, yes. So again, 1154, right? You add another thing into it. So then you can see, yes, divided by 13, remainder 10, right? It's remainder 10, plus an 8. And again, you have plus a 385, 1539 divided by 13, remainder 5. And 1924 divided by 13, remainder 1, right? Plus 8, plus 8. So then you can get the answer, right? You can see among it, do we have a remainder 11 here? No. So the sum being 31 also not can be, right? Also cannot. So we just make it 31 also minus it, become 30. Right? For the 30 here, we already have 6, 4, 6, and 10, 10. Where is it? It is already in this one. Right? It's already in this one. 1154 here. So we know it is 30. Right? 1154 is a correct number for it, giving you the remainder 30 here. So then you just try it out. The answer here is 30. So any questions here? If no, then we can finish today's lesson. Is there any easier way for question 30? We have discussed, but yeah, for now I don't find an easier way. Do you have an easier way? For this, I think the way is just you try, and you get the answer here. Yeah, this one is, I think, is not that good. But yeah, I think it is already a good way here. So for this question, do you have any questions for this paper? No? Okay, everybody say no. Trying is very tiring. Yeah, it's a lot of calculation in question 30 here. Okay, so if no problems here, then I end today. So see you next week. Yeah, bye bye.